We are going to be learning how to factor trinomials. A trinomial is a polynomial that has three terms. When you start factoring anything, you always want to look for that greatest common factor. Another suggestion is to make that leading coefficient positive. Usually makes it a little bit easier to determine what signs you need in each factor. The way I'm going to teach this is called the guess and check method. It's one of many. There's a box method, a grouping method, and some other methods that I don't even know the names of. But whatever you feel comfortable with, that's fine. Let's look at this first example. Notice that it is in what's called standard form, in that the x has a squared, then x, and then no x's. That's descending order of your polynomial. This is the easiest type of trinomial there is to factor because that leading coefficient is 1. And if that leading coefficient is 1, all you need to do is find two numbers that multiply to get the last term, but add, and when I say add, that means add or subtract because we have negative numbers, to get the middle term. So what two numbers multiply to get positive 45 and add to get negative 14? And of course you're going to say negative 9 and negative 5. So we want to put two sets of parentheses. We need x times x to get x squared. And it doesn't matter what order you put the numbers in, because we know negative 9 times negative 5 is negative 45. But how do we get that negative 14x? Well, let's just check. We're going to use that FOIL method. So x times x is x squared. X times negative 5. Negative 9 times x. And negative 9 times negative 5. So notice what happens is that these two combine to make that middle term. And that's the hardest part about trinomials, is to get that middle term. So once again, if the leading coefficient is 1, we just want to find two numbers that multiply to get the last term, but add to get that middle coefficient. Let's look at the second example. The leading coefficient is a positive 1, so we just need to find two numbers that multiply to get the last term, 10. So the only thing that multiplies to get 10 is 1 times 10, or 2 times 5. To either pair of these numbers, add or subtract to get the middle number of 6. No. So we cannot factor this. This is called prime. When you cannot factor something at all, no GCF, nothing, that would be prime. Just like a prime number can be only divided by itself and 1, a prime polynomial can only be factored by itself and 1. As we look at number 3 and 4, you will notice that the leading coefficient of x squared is not 1. Let's look at number 3. Also, what I don't like is that leading coefficient on number 3 is negative. What can I do about that? Well, first of all, I notice that all three of these numbers are even and they're divisible by 2, so there is a greatest common factor. Is there a bigger number than 2 that goes into 8, 16, and 40? Well, I think 8, because 8 times 1 is 8, 8 times 2 is 16, 8 times 40 is 5. So I can take a GCF of an 8 or a negative 8. I'm going to choose a negative 8. If I divide all of these by negative 8, let's see what happens. That leaves me positive x squared minus 2x plus 5. And that then makes this trinomial with a leading coefficient of positive 1 much easier to factor. That's not prime because I have factored out a negative 8. Now I'm going to try to find what two numbers multiply to get positive 5 but add or subtract to get negative 2. Well, the only thing that multiplies to get 5 is 1 times 5. Whether you add 1 and 5 or subtract 1 and 5, you cannot get negative 2. So this trinomial is prime. This one is not prime because I did factor it with that negative 8. So this would be the correct answer. Now let's look at number 4. We don't have a leading coefficient of 1. I don't see a GCF. This is where you have to do that guess and check. So I'm going to put two parentheses. And what I want you to think of is what numbers multiply to get 20. Don't think about the signs right now, just multiply 20. So I know I have 1 times 20, 4 times 5, 2 times 10. What multiplies to get 6? 1 times 6, 2 times 3. So we have to find the right combination when we multiply it and do all the right signs to get a positive 7 in the middle. Well, I'm just going to start with the smaller number. I'm going to try 2x times 3x. Now here's my biggest hint. When you're deciding what numbers to put where, you can never put a number in a parenthesis that has a common factor, meaning I could not put a 2 here because 2 and 2 are both divisible by 2. I couldn't put a 10 here because 2 and 10 are both divisible by 2. They have a common factor of 2, which means if 2 and 3 work, 2 times 10 cannot work. So let's try 4 and 5. Can I put the 4 there? No, because I know 2 and 4 have a common factor of 2. So if 4 and 5 work, the 4 has to go here and the 5 has to go there. I'm looking for that middle term of positive 7. So let's do the inside. I'm doing that part of the FOIL process, the F-O-I-L, and I'm doing the OI part. All right, so 5 times 3 is 15x. 2x times 4 is 8x. Can I add or subtract 15 and 8 to get positive 7? Well, I think if I make the 15 positive and the 8 negative, that would give me a positive 7x. So if I put a plus here and a minus there, checking my signs, positive times negative gives me that negative 20. So let me just write that a little bit neater. 2x plus 5 times 3x minus 4. Again, if you check that by foiling it out, you're going to get 6x squared minus 8x plus 15x minus 20. You put those together, and that's going to give us our positive 7x. Now what would have happened if 5 and 4 didn't work? Then I would have tried 1 and 20, knowing I could not put the 20 there because 20 and 2 are both divisible by 2. Let's say all of that didn't work. Then I'd have to go try the 1 and 6. A lot of trying, but you will get better at it. That's why it's called guess and check. Guess and check. So you're trying to make intelligent guesses. Looking at number 5, our leading coefficient is not 1. There's not a GCF that I can factor out. So I'm going to go through that process of what multiplies to get 12. 1 and 12, 2 and 6, 3 and 4. But the good news is the only thing that multiplies to get 2 is 2 and 1. So I'm going to put 2x times 1x because I know that gives me 2x squared. I'm going to have that set. And then again I kind of go through here. Well, I want you to notice something. This pair could never work because a 2 or a 6 here can't go with the 2. So we can cross that out. And now I've eliminated two different things. So let's try the 3 and the 4. That's kind of the normal choice. You should know the 4 cannot go with the 2. So I'm going to put the 3 here and the 4 there. See if I can get my negative 5. So that's 3x. That's 8x. If I make that negative and that positive, that would give me negative 5x. So that needs to go there. That needs to go here. Now just double check your signs. Alright, so if I FOIL this whole thing out, I would get 2x squared minus 8x plus 3x minus 12. Combining those, I get my minus 5x. So I know that is the correct answer. And again, if 3 and 4 didn't work, I would have tried 1 and 12. Let's look at number 6. First of all, that should look backwards to you. It's in just the wrong order. So let's rewrite it in what's called descending order. So we have 3x squared minus 22x plus 24. Those numbers look kind of big, so let's see if we have a GCF. 22 is not divisible by 3, No GCF. So we just have to kind of take that plunge. The good news is that 3 is the only factors of 3 are 3 and 1. So that's good. 24, that's the bad news. We have 1 times 24, 2 times 12, 3 times 8, 4 times 6. Way too many guesses, but let's just give it a go. So we have 3x times 1x. So we're looking at here, and we're seeing, all right, I've got to get something that multiplies to get 24. Well, if we start with the smallest, if I try 4 and 6, I cannot put the 6 there because 3 and 6 have a common factor of 3. So I know that's not going to work. But let's try the 4 here and the 6 there. I'm trying to get that negative 22 in the middle. So I'm going to do that 4x and 18x. If I make them both negative, I get negative 22x. Hey! And the other good news is a negative times a negative is a positive. So I think I have found the right answer. But let's just check. If I FOIL that out, let me just write that answer again so it looks a little bit less messy. I've got 3x squared minus 18x minus 4x plus 24. I know if I combine that, I get the negative 22x. So that's the right answer. I was very lucky. I made a guess. I started with the smallest numbers. I knew I couldn't put 6 with the 3, but if that wouldn't have worked, then I would have tried this, and I know I couldn't have put the 3 with the 3. That didn't work. I'd try the 2 and the 12. If that didn't work, I'd try the 1 and the 24. And if none of them worked, that would be prime. And that's the frustrating part about trinomials. You have to go through all these tries before you realize, that was prime. The good news is that this one was not prime. One more time, that was the correct answer. So let's look at number 7 and 8. Ooh, number 7 has some x's and y's. Does that change the situation? Not really. Okay, notice that our x squared is first. You could put the y squared first. It doesn't matter. There's no rules. But the 8's positive, so let's leave it like that. I don't see any greatest common factors. 8, I've got 1 and 8 or 2 and 4. The good news, 5 is just 1 and 5. So as I put these parentheses, we need to make a guess. I'm going to try the 2 and the 4 just because I see that 6. I could be wrong. So I'm going to put 2x times 4x. The 1 and 5 can go either place, but notice since it has a y squared, I need to put a 1y and a 5y. Now we're trying to get that 6. So let's see, that's 4xy. That's 10xy. If I make this positive and that negative, that's positive 6xy. So this negative goes here, this positive goes there. Checking signs, I need a negative 5y squared, so I have a negative and a positive. I got my positive 6xy, and I was just lucky on the first guess. Maybe I would have put the 5 and the y on the other place and it wouldn't have worked. Maybe I should have intentionally showed you that I guessed wrong, but it was just a lucky guess. Let's look at number 8. Ooh, x to the 4th. Maybe there's a GCF. But no, they don't all have x's. They don't have a common factor. But the good news is just like we started at the top, the leading coefficient is a 1. So I just need to find two numbers that multiply to get negative 5 and add to get positive 4. Well, that's easy. It's going to be plus 5 and a negative 1. But instead of x times x, we need x to the 4th. So that's x squared times x squared. I just want to show you that that actually works. X squared times x squared is x to the 4th. Then I'd have minus 1x squared and plus 5x squared minus 5. Combine like terms and I have that. Is that my final answer? No, it is not my final answer. And that's because right here is the difference of two squares. So I'm going to keep my x squared plus 5, but I'm going to continue factoring x squared minus 1. And remember, the squares, one is positive, one is negative, and now you're done. So sometimes even with trinomials, you need to make sure that you're as far as you can go. challenge is for you to search the internet for alternate ways of factoring trinomial. Some of you have learned like with a little square, that kind of thing. Some of you have learned a grouping method. Would love it if you would share with the class your way of factoring trinomials.